good. Alright, we got visuals. We have a stream. Yay. Welcome, my name's Fraser Sharp, and this is interesting. Let's just clean up after the cat. Thank you, cat. That was a beautiful sneezing session you've just been through. Fantastic. Muppet's still sneezing like a good un. Here we are. Look at that picture, eh? What are we looking at? We are looking at our first tile. Yeah, a tile. This is our test square. And it is square, it's just lying down on the floor. And we're looking down on it from above at 45 degrees. Oh, yeah, there you go. You can see it shoots off into the distance. There we are. Everything's working. I think we even have Q. Yeah, we do. Excellent. And the escape button works at long last. Wow. 35 degrees C. Nothing's wrong there. Alrighty. What have I been up to? Well, I've been cleaning stuff up, that's for sure. Just close that. It's a little bit too far over, so let's bring it back a bit. There we go. Lovely. So, fix memory leaks, done. Camera 3D, done. Give the camera movement, done. How did I give the camera movement? Well, it was pretty easy. In our run, set up the camera, yeah. While running, I just did that. Updated our game. So, there you go. Just looked for the scan codes using SDL and added and minused 1 as, or 0.1 as applicable. Recalculated our camera view matrix and of course just left everything the same after that. Sent in the uniforms. Got our vertex array object. And yeah. Done. It's not the greatest way of doing this, is it? That's all going to change anyway. And as you can see, it's in a different file now. I'd had enough of having 1,000 lines of code in one file. So we've only got main in here at the moment. So that's all we've got. We'll be developing more down here today, hopefully. All the program structures have been moved. All the program functions have been moved. Sandbox now has maths for our matrix utilities. It has OpenGL for our shaders. They've all been moved into there. So, everything's been updated. Well, refactored. I got bored. What happened to me coffee? Muppet, what have you just done with me coffee? Okay, it's all the way over there. Thank you, Muppet. Do you want to go in here? Let's just go in there for a sec, thanks. Okay, I've got a cup of coffee. So refactoring was just taking everything out of the main, the start, sandbox CPP, and putting it somewhere else. Of course, we won't need as many includes. We just need sand in it to do the window. And of course, we now have a game.c in our core source code. So we have begun. I think we've got a lot of the basics done now. Except the only thing we haven't done that's in the basics is load a model from disk, hard drive, or SSD as it might be in the future, or whatever. We haven't pulled in a model, a 3D model at this point. We're still playing around with our test thingy, which is what I prefer to do for now. Obviously, as the game develops, things will change. And I hope everybody's okay today. Coronavirus hasn't eaten you alive. It's nearly eaten my cats alive. But hey ho, you can't have everything. And it's Wednesday, yeah. Good. So, first step in the game. Let's see what notes we've got. Alright. Graphics in OpenGL. Yeah, we've decided on that. We've got a camera. That's okay. Map tiles, yeah. I think we will go down that route, map tiles. Probably. We've got shaders. Gravity and collision. That's going to be fun. And we now have a little bit of interaction and a camera that moves, okay. So far we haven't got much that represents a game. And what I've been doing is hunting for a roguelike that seems to follow some kind of common sense. Because programming a roguelike from scratch, we're going to require a level. Okay. So we're going to need a dungeon level. Which can be stored in as the game progresses. Yeah. I've decided on the simple road to start simple. So all I'm after first rooms. Generate rooms. Generate corridors. But we're going to have to do that intelligently. Okay. I just need to know something. I need to know something that's going to be key to everything else. Have I still got standard I/O? Yes, I have. I do this with every language, don't worry. Might seem obvious to some people, but what does true equal? Let's find out. True equals 1. Okay. That's important. It's very important. True equals 1. Okay, let's put that in my notes. That means false equals 0. We now need to know that because we are going to make a map. And I have a feeling that we have a way of easily doing that in stdlib. Where's my mouse pointer not looking at it? Never mind. And it should be calloc. Allocates a block of memory for an array of number of elements as a size. Blah, 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 blah. Hello, mouse pointer. Come to... got you. There we go. And initializes all its bits to 0. So we can do a C allocation from the standard library. Right. I wonder. Right. We'll need a dungeon level. And that's going to contain a map of booleans. And we want to use calloc to allocate them. God, I haven't done this in so long. I'm going to define map width go for 80. Hash define map height. We'll call it 40. So actually I don't want dungeon level, I want current level. Is going to be bool tiles. Oh wait a minute, we're going for zeros, aren't we? Walls. Let's see it the naive way first. Let's make it into a two-dimensional array. That's not going to work. Not in the long term, anyway. I just want pointer then, don't I? So what I want before we start our run is to create a map. Create level. Dungeon. Right. That's what I would like to do at this point. So that's where we're up to. We'll make it void for now. I don't know what variables we're going to be doing. And we'll need a semicolon there. Right, so this is where we're up to. We're actually going to start making a game. So how do we create a dungeon level? We first of all need to obviously make one of these structs. Current level. I'm hesitating because I'm about to do that. I don't need to do that, do I? And level dot walls. We need to allocate memory to. How do we do that? Size of each element. Okay. Int star pdata. Pdata equals int star. Alright, so there's the line that I want. That's the next thing, so... so... yeah. I don't like the way I've done it up here. I've done it my C++ way, haven't I? It's a bool star, walls. Sorry, it doesn't matter where you put the star, it just reminds me that it's a bool star. Equals bool star calloc, open brackets, close brackets, where we take map width times map height, and we want the size of a bool. Yep. The reason why I'm using calloc is because it sets everything to 0. So we have now, according to my notes, set everything to false. Yeah, I'll have floor, not wall. Makes more sense to my mind. Set all Alec will set all locations to false. In other words, what that now says is there are no floors. Alright, where's R&D? Hey, Setu12, how you doing? We're building a game at long last. I've finished messing around and I'm going to create a dungeon. I've done a little bit of OpenGL so far using a little bit. It's Linux? No, it's C. Doesn't matter if it's Linux or not. It's cross-platform. But yeah, I'm on Linux. Manjaro. I can switch to Windows if people want me to. Yeah, I'm using Linux here, but I can switch to Windows if that's what people want. I don't care which operating system I use. My preferred operating system is Manjaro, which is Arch Linux. I find Ubuntu too slow nowadays. And as for Windows 10, it's surprisingly slow. The irony is I'm using a Microsoft text editor called Code to do my coding. That's because I can press F5 and it'll do something like that. There you go. That's my first tile, my test object in OpenGL. Very pretty, very colourful. We're using OpenGL version 3.3. I've got the drivers for 4.4, but hey ho. And yeah, we're deleting things properly now. Good. So yeah, everything's working. Things are looking up. Now, first of all, this current level, we're going to have to keep hold of it. I've decided to use C, by the way, because I've just had enough of programming languages. So I've gone back to my roots, I guess. I'm just sick and tired of being messed around with programming languages that just are silly. I mean, I've just been, what was my last one? Java. I wrote a full 3D 3D engine in 5 days. It's on my YouTube at Fraser Sharp. If you look up Fraser Sharp on YouTube, you'll find it there. And it didn't really work out too well, so I've gone back to C now. You're writing a render in Vulkan. I do. If you catch some of my past streams on here, I have Vulkan on here at the moment. Vulkan's very simple compared to OpenGL, I think it is anyway. It makes more sense. It's not difficult at all. People say it's dead hard, but it isn't. It's just more sensible. OpenGL is, I think, more difficult. No, I've finished with Vulkan. The funny thing is, can I ask you a stupid question? On Vulkan, it uses a layer system only in debug mode. It uses Vulkan layers for debug mode to be able to catch errors. In Arch Linux or on Linux, how did you get your layers? Because my layers don't work. I'll show you. I couldn't actually get it. I've got Vulkan here, you're alright. You're supposed to download the SDK. Yeah, well, how do you link your SDK to IntelliJ? That's what I need to know. You see, I'm using IntelliJ for Vulkan. If it'll ever load. It might load, then again it might not. I was doing Vulkan in Rust. Ah, right, you're in CMake. Well, that buggers things up. Never mind. I'll show you how far I got anyway. May as well. I think it does, yes. No, that's fine. That's fine. I'll just take a look at this and I'll show you how far I got in like a couple of days. I've got the project still, but it'll get wiped out eventually. All right, well I might be able to help you there. Just getting back into it. I'll just go through it. God, it's so slow the first time I do it. I'm on a potato machine, so please bear with it. I mean, this machine was made, well, parts of it were made in like the year 2000. Alright, just did a tutorial, that's fine. Don't you worry about it. You can ask me questions on anything, by the way. Oh, VEZ, yes. I use Rust for my programming here. Okay, I don't really want the update. And as you can see, go to the top. Right, so you have your initialization, basically looking at what extensions you can get. You then create, or you do your device, which is your screen basically, find your device. You create a window, choose which GPU queue you want to use. Queue is the same as a thread in normal language. So you choose your thread on your GPU. You create your device with how many queues you want to use. Then you do your swap chain. So in Rust that looks like this, swap chain new. Then you create your buffer, in this case a vertex buffer, which is very simple to do. Then you create your shaders. There's the two shaders that I used. Just popped them in. Then you create your render pass and your pipeline. Make sure you have a resize callback for when somebody resizes a screen. Create the frame buffers, initialization complete, that's it. And then you're in your event loop. And your event loop is event, redraw, event, cleared. Clear what you've drawn, so clear screen. Swap chain equals a new swap chain, frame buffers, recreate swap chain, for me anyway. Do your image and draw. There's your draw. Oh, found another one. Forever finding these. That's it really, because you've got to match your futures for your output. So that's basically it. The helper function here is just for a callback for window resizing. It follows the same idea. It's just looks different. This is in C, by the way. This is Rust C. So it looks slightly different to C, but it's not that much different. Let's see if this thing builds. It does. There you go. Just sticks a triangle on screen. Whoopie-doos. That's as far as I got. I had to give up at that point because I decided not to use Rust anymore for development. So I stopped because I'm streaming and I have to develop in something that everybody can use or learn, and that isn't going to cause massive build lag. I found that Rust was doing that. As you could see, the build on that was a bit too much, whereas here in code, I press F5, it's done. There's no build lag. So I can't accept any build that is over 10 seconds long. So if it's over 10 seconds to put something on screen, I can't accept it. It's a slow build because there's so much bloat. The Rust language is currently suffering from its childhood eating too many sweets problem. It's going through a childhood stage, which means the libraries that you use are horrendously bloaty. Rust itself compiles in a flash. It compiles at the same speed as C, but as soon as you use a library, it all goes down the pan. It really does. They're just so library happy. They don't seem to do anything for themselves. So I've gone back to C, so I do everything for myself. So I wasn't over. Don't get me wrong, I love Rust. I want to program in Rust because to me it is the next evolution of C. It's the evolutionary successor to C. But until they get control over the libraries, no, C isn't way faster. No, it's about the same. Rust goes directly through. Rust was built in C for programmers of C and C++. So it was designed to run at the same speed as C. And it does. If it is slower, it's only fractionally slower. But I think they've done a lot of work since the beginning stages to solve those problems. But the build problems have got, sorry, not happy. So I'll come back to C to do something, like create a dungeon level. Now I've just created a two-dimensional array. Can I use that as a two-dimensional array? Yes, I can. Yeah, nobody's replacing C. Well, if Rust ever gets itself sorted out, it's with Mozilla now own it. So if Mozilla can actually get it sorted out, I mean, they've got the money to do it, then yay, I would swap to Rust tomorrow. If I knew that I could use something like SDL and it wasn't going to make my compile times into 56 seconds. Which it did, by the way. So, yeah. I'm using SDL here, and there is no compile time. I'm using Glue, OpenGL, GLM, and SDL. Now, if I was to do that in Rust, I would be on 1 minute compile times. So, no thanks. I'll stick to C for now. So now what I have to do is work out how to make a room. So, I've now got a level with no floors. So we need to make, sorry, I do all my programming in English, to be quite honest with you. Make a room. No, that's going to be a random room with a max size and width. Place room into map. What is it? It's closed source, but I need to use Vulkan because I always wanted to write a ray tracer. I don't think Vulkan's any better at doing ray tracers than OpenGL. But don't quote me on that one because I don't know. I've not done a ray tracer in Vulkan yet. I mean, the last time I did a ray tracer was in C, and it was about 1998. Yeah. So I'll have to do a semi-ray tracer in this anyway. It'll just be a shadow line calculator. Yeah, Vulkan has the RTX extensions, yeah. Makes it easier. I mean, OpenGL does now, if Intel will support it. If you're using a Radeon GPU, then Vulkan definitely. If you're using an Intel GPU, you'd have to be on a 2020 or above, wouldn't you? I don't think the 1080s don't support it. Oh right, you're doing ray tracing on the CPU. Oh dear. Good luck. No comment. You'd be better if you're using Vulkan, use the compute shader, mate. Otherwise, you are going to be very slow. And that's what the compute shader's for. But now, on anything above a 1080, there on the graphics cards, there are ray tracing shaders as well. So they may become a standard thing of GPUs since, well, if you've got 950, stick with your CPU to start off with and use your compute shader if you need to. 950s have a compute shader. I'm on a 670. Something from, I think this was made in the 90s, my graphics card. It's a GT 670. Did I mention I'm on a potato machine? Well, I could go fancy, but then how would I gauge if somebody can run my program? So I use a potato machine to develop on purpose. No, it's okay. I was going to go ahead and actually make a renderer out of Vulkan, but never did. Programming is not about the language, it's about the way you think. So it doesn't matter what language you throw at me, I'll still create the same goddamn code. It'll just be worded differently on the screen. That's all. The only thing that changes is the syntax. But my first language was assembler. I learnt to program in assembler language at the age of no, I won't tell you my age. It was in the year 1970 was my first program, and it was to hack some software. It was wonderful. The computers in those days were a lot better than they are today. These computers today just, well, I don't even think they're going to survive. They're that monolithic now in code base. Did you know there's over 50 million lines of code in Windows 10 alone? That's without the drivers. It's too big. They can't support it. They'll never find half the bugs. I mean, when they released it in 1995, it had over 3,000 bugs. And it was a lot smaller. I think it was only I think it was about 10,000 lines of code in them days. Place room into map, setting floors to true. Make sure that no two rooms overlap. Okay. Max width and size. Max width, how's about 16? Let's just pull numbers out of the air. Because I'll want to change them. Max. Yeah, I will want to change them later on because I want to tweak this. Divide by 10 times by 2, 16. There you go. Divide by 10 times by 2, 8. It doesn't sound right, does it? We'll make it 12. I don't know. I had a computer when I was young that was far superior to the computer that I am now programming on. In fact, I don't think today they have a computer that's faster than it was. Speed of computers has gone downwards since the year 2010, quite steadily. This computer speed that I'm using at the moment is 3.2 gigahertz. Before Intel went multi-core, the speed of computers was up to 7 or 8 gigahertz. Now, if you can't even go that fast. But when the Pentium split its cores and became the basis architecture for something called Sandy Bridge, gigahertz went out the window, number of cores went up. So now it's just number of cores. Determines the power of the computer rather than the speed. Software is really bloated, yes, which is why I'm writing in C. Right, so we've got a max room width and a max room height. So let's make a room. We're going to, well, it's an unsigned internet uint. I saw a video comparing a modern Intel CPU to an old AMD CPU. The Intel CPU was actually slower in a few tasks. Yes, indeed. Hate to say it, but you're correct. uint, that'll come out whatever size the processor is. I think I'm in 64, but never mind. Room underscore width equals r rand mod modulus max room width +4. No. I'm going to use my all-time number +3. Everything should be a 3. If you're unsure of something, it's always 3. uint. That goes to the same as with the if statements. If you don't think you've covered every option, there's always 3 options. Room height height equals rand mod max room +3, because I don't know what it's supposed to be plus. Right, so we've made a room. Place the room into the map. Okay. Do English. And that's going to be mod goes from 0 to the number you give it. Or 1 less, is it? No, 1 less. So if it is 0 plus 3, okay, yeah, that'll be alright. So uint, its x position. Will be rand mod map width. That will give it 0 to 1 minus. Zero to width minus 1. So it equals 2. No. I'll have to accept 0 then, won't I? Well, it's plus 1. That gets it from 1 to the map width. Yeah, no, I'm just going to take that. I'm going to take that for now and see what happens. Don't try and think it too. If I try and think it through, it'll never work. I'll never calculate it. So let's calculate stupid ones first, make all our mistakes, and correct them later. Map height. Height, please, thank you. Alright. So that will give us an X and Y. Assuming they don't overlap. Assuming room does not overlap an existing room, we can do the following. We can carve room at position X, comma, position Y with room width and room height. Oops. and that will be the end of that. That's that function done. So that's the whole create dungeon level that we're only going to go through it once and carve out one room to start off with. So that's going to be a void. Carve room. This is going to be, they're all just uints, aren't they? We don't need the fact that they are rooms anymore. Because it says it in the name of the function. And that's the final thing. Okay, that's its signature. Which we will declare up at the top. There we go. Right, so how do we carve out a room? We have to loop through. We have to loop from x to width. For I doesn't matter, uint I equals x, whilst x is less than. This is where I can claim my 1 back from the right hand side. So it'll be 1 less. So we'll have to increase that by 1. Because I'm going to reclaim it here by not putting equal to. Less than width. If I put equal to, then we will go right up to the right hand edge, and I want a gap of 1 space at the right hand edge. I want a border of 1 all the way around, so that equals top as well. That will happen automatically, and then as we go down, yeah, so we've got our borders. Fantastic, it's automatic within the algorithm. Oh, that doesn't help. Let's get the right variables going, shall we? And for and we're going to have j equals y. I think you can write this yourselves now. J is less than height, maybe. H-E-I-G-H-T, is that right? Yep. And J++. So we're just going to loop through each one, and we are going to take our map. So it's going to be Alright, I'm going to cheat. I am going to cheat. For now. And put a static. There's no point in putting it there because it'll never happen. Put it there. Thank you. That is now a global. Okay. So G underscore level, and we will have at I J equals true. And that's what I was expecting to happen. Damn it. Oh no, G level dot floor. Might help. Right, so we're setting that to true. How do we render that? That's in the wrong place. Order matters. It goes down here. That has to go after that. Otherwise we can't do it. And that has to be accessible in there. So I'm going to cheat once more. I'm going to put it in here. It's a structure. So what I'm going to do is I'm going to put this into structures in the library. It's in a header file, isn't it? So I don't have to recompile. Let's tidy this up a bit. There we go. And all I'm going to do here is hash include sand structures.h. Right, so you do have current level now. Stop lying to me. No, you don't. Actually, we can put that static in there as well. So it's out of the way. And I've namespaced it, so we should now get errors. Yes, good. Just tell it where it is, might help. Alright, yeah, of course. That's alright, that's fine. It's all namespaced now. And there's the other one. So all we've done is we've taken it off and shoved it in the library, so that everybody can find it. I've still got a red line somewhere here. Going to this. No, I haven't. It's just not updating. Microsoft, can you get your act together, please? I don't know. No, it's still telling me I have a red line. Expression must have a pointer to object type. Thank you. It does now. No, that's fine. Okay. Why does it make an error in sand? Namespace sand. Expression must have a pointer type. It is a pointer type. Oh. Got you. I think I know what it's complaining about. Yeah, I think using a pointer at this stage might be a good idea because we've got C allocation now. Right, that should... Must have a pointer type. Pointer to object type. It has. I know what it's getting at. It's the way I've done the brackets, isn't it? Ah, damn it. There's a way of doing this so it'll work in C. Saw a video comparing a modern Intel CPU. Yeah, a few instructions. Yeah, bitwise shifting and stuff, yeah. It's more complicated in newer languages. As are type defs, which I try not to use, as you might have noticed. Although uint is a type def. It isn't an actual type in C. So I shouldn't use it really, I should use unsigned int. But I'm lazy. But there you go. Right, I do know how to do this, but I can't remember how. I could just do I times J. Instead. If you don't already know, two-dimensional arrays in memory are held as consecutive positions, and that's in any language. They are not held as two separate, like, they're not separated out. So that notation is exactly the same as that notation. So I'll use a notation that works. Simple enough, isn't it? So when we come to render, we have to use the same notation. Let's try build. I got a warning. Okay. How does C allocation give me a segmentation fault? Because there isn't anywhere to put it. Right, got you. Structs do not initialize their own things, though. It's not able to do C allocation, okay. That's a bugger. C allocation problems. How do we get around this? Returns a void star, that's correct. I haven't got an enter key, thank you. So our sand G level dot floor should be coming up with this. Floor equals floor. Okay. It's the way I've declared it is the answer. Try that. Nope, still doesn't like it. Flexible array member. No, it's not going to let me do it. Oh, wait a minute. Maybe it has. Can I convert bool to bool star? We don't need to. You shouldn't be doing that anyway. We're still at bool star, are we? Oh no, it's gone backwards again. Yeah, that's what I was thinking. But you're telling me that that's an error. Invalid argument. Invalid type argument. Star. I wish this thing would make its fecking mind up. Floor is a pointer to that position. Equals true. We have to allocate this differently. I could do with a C manual. Has anybody got a C manual handy? How to allocate memory to a struct containing a pointer. Right, I'll work that out. Oh, wait a minute, there was something else in that lot, wasn't there? Ah, bollocks. Oh gosh, I hate it when it does that. Can you please compile? No return statement. That's what it said. Current level went global. Oh, of course I can't do that. I haven't even created a debris. Okay, I'm doing it wrong. That's why. Static current level, G level, yeah. G level floor. Yeah, I'm not doing it wrong. Interesting. Right. Well, I'm going to go and solve the other problem that I've got now, which is how do we replicate this on the other side? I'm not bothered that it doesn't work yet. I can work that out later. So when we're rendering, we want to go through all of these. And at each point that is true, we want to render. Okay, welcome to the renderer. It's not very good yet, is it? Right. So if gonna have to cheat again, aren't we? Which makes sense because I'm cobbling this together. Okay. Our hash defines that you're gonna have to move over. They can be global. Not bothered about that. Map width. Map height. So if that is equal to true, then we render. But we have a problem. Our model matrix will be wrong. So we are going to have to change our model matrix for each model. Which means we have to calculate our model matrix for each model. Camera view doesn't change. Model matrix does. It does now anyway. So we'll pop you down here. And our model test square. Got ya. Well, we actually called it though. Test data. Okay, fair enough. Now we have to go and modify everything. Damn you. That's all the test data we have. Oh. Interesting. It is all the test data we have. Ah, that's a goof. We'll need at least a position adding to that. I'm going to need to add a position. We are going to need a position. a vec 4 position. That'll do. Test data GLM colon vec4, and it's going to be 0.0f. Don't start it off anywhere is the answer. Start it at nowhere. Except for that one at the end. So that changes now. Equals GLM vec4. The x will be I. Start those at 0, please. So that's going to be I, and that's going to be correct. No, it's not, because that needs to be a float now. It's a different type. And we can't have that. No, that's okay. Leave it as U in. Doesn't matter. I have to do conversion. That does matter. So float I, comma 0.0f. Don't want to get going upwards anywhere. And then we'll have float j. Comma 1.0f. Yeah, that'll work. Calculate the model matrix, which doesn't take into consideration any of that. Signature has to change. Wow, I just realised we don't need to go that far, do we? We can make this even simpler. I think I've just overthought it again. That's not even needed. All we need is float I, comma, float J. We can just change the signature there. To float X, float Z. What's wrong with float Z now? Come on. God's sake, Microsoft, can't you write anything that works at a sensible speed? Right. Right, so we can now translate. Yes, good. Don't need any rotations. And don't need any scaling at this point. Okay. So that can now do a draw elements. No, it can't. Yes, it can. Yes, it can. Excellent. Sorted. That will work. Gone off the screen. Can you come back on the screen, please? Okay. Those are the three commands that we'd need to use to calculate the position of the model and where to place it on screen. Yep, that would work. Why have I got so many going out here? That's annoying. That's correct. Okay. That's made it more complicated than I wanted to, but I want to try and keep things as simple as possible at this stage. But that is the code. All we have to do now is position the camera in the right place to be able to blooming see it. be at the top. Alright, so the camera position is going to need to be halfway across the axis. We went by 80, so let's just say 40 for now. Upwards. I can already see a problem. We'll say by 10 in the air, and that puts us at -10 away. That'll keep the rotation correct in the x-axis. But we want to turn it around 180. Okay, because currently it's looking down the -z axis, so I have to turn the camera around, I believe. Now if the camera's turned around a bit, my WASD is now in the wrong direction. Oh, I'll work that out when I've got it working. So will that build? Just that one problem there on game C70. I didn't alter anything up to game C70. What? Did we not forward declare? I thought I'd already done it. Anyway. Why is that a problem? Expected an expression. Why? That's a function. Test data. We didn't touch test data. Have I left a dangling semicolon somewhere? Don't understand why that's changed. Test square. No, that's wrong. Oh. Yeah, our construct is now not correct. Got you. Sorry, that's in the wrong place. It returns a test. Yeah, test data's wrong. Right at the end we construct it, don't we? That's where it goes. Turn data. Oh, yeah, that satisfies the condition there. I don't see why you want us to call test data with anything. Okay. Test data is now set to the correct place. Okay. Should be back to the original one now, please. Game C70, location 5. Did I mess it up in here? Test data. Storage, no, there's nothing different here. Alright, I think that isn't correct. Because that is correct. So it's looking at something completely different. God knows where it's looking. I'll have to. Do we get a stack trace? No, we don't. There should be other errors, that's why. Right, the errors are not right. Great. Fine. That means I've got a lot of debugging to do. Yay! So that's what I'm going to go and do. How long have we been on for now? Oh, nearly the 2-hour mark. That's how much time I wanted to spend on coding. And I'll go off and do some debugging. Fun. Yeah. But I think that says everything that I need to do. That's good. There's nothing wrong with that file. Yeah, I'm happy with that. And what I'm not happy with is this here. Okay, So in the next session, we will go on to add more rooms once I have the control flow of this sorted out, and we can display our first room. That's already set up in the code. All we have to do is be able to use this calloc properly on our floor map. Which doesn't seem to be happening right now. Okay. In the meantime, I'd like you all to take care, and if you can, try and have some fun. And I'll try and find the stop button. Right, I got the right mouse this time. I think we'll be alright. Take care, peeps.